Welcome back, guys. This will be day 11 of me learning TypeScript. Day 10, I did classes. Okay, there wasn't really much in classes. So now I'm going to do utility types. This is chapter 12 in this put.dev thing that I'm reading. And then 13 is generics, which is going to be interesting, and then conditional types, that's way and then local development. I think they're just gonna teach us how to run TypeScript like using TSC, whatever, node or band, whatever. No, band runs TypeScript, right? And then there's Dino. Okay, but I think they're just gonna talk about TSC and how to install TypeScript and whatever. Okay, so let's just continue. So the only thing that's left that's really important is generics, because as I've said, the last time I read about generics, I didn't really go that deep. So maybe in this course we will go deeper, and I will actually write some code to test my knowledge in this sort of thing. So let's just start. First, single source of truth. It's incredibly common for a TypeScript code base to amass a truly absurd number of custom type definitions, hundreds of interfaces and types, all with a slightly different number of fields for a lot of the same entities. You might run into crazy stuff like this. Your user without ID. Okay. Okay, this is bad. I can see why. We generally try to avoid redefining the same types over and over, and instead try to follow a single source of truth approach. For example, here you could refactor a little bit. You can do this. Yeah. Oh, I'm like, can't you just say that type sometimes won't be there? I mean, it could be there, but sometimes it can't be there, right? Using the question mark thingy. Okay, let's just read further. There are other techniques to do this even more cleanly that we'll cover later in this chapter. In other words, we try to define our types once and build type systems that rely on inference and type transformations to derive the types we need automatically. The way we make that way, when we make changes, we only have to do it in one place. In our second example, updating without ID will now automatically update user as well, a big win. In our second example, updating user ID will now automatically update user as well. Okay, it's just inheriting those types, man. It's not a big deal. Still kind of similar to what is happening here, but we didn't have to write it. Okay, you get it. Okay, you get it. Okay, yeah. Okay, which of the following is true about a single source of truth approach? We can derive multiple types from one main type. There it is. It's best to copy A. Right? Duplicating code makes it easier to handle special cases. Okay, should be this. We can derive multiple types from one main type. Okay, see here we can derive user from that because it just says one extra type, which is ID, one extra property. Okay. Partial utility type. There are several built-in utility types that transform existing types into new ones. One of the most useful is partial, then taking a type, which makes all properties of a type optional. For example, we have type user, ID, name, email, and then without partial, ID is a string, user info, and then see everything is with partial. Okay, partial, and then user. Okay, I see partial. What does partial do? Okay, let's see. One of the most useful is partial, which makes all properties of a type optional. Okay, yeah, it will make all properties of a type optional. Okay, instead of copy pasting the type definition, the partial utility type allows us to generate a new type based on existing one. That also means if the original is ever updated, the new type created with partial will automatically have those changes. Yes. Nested object partiality only makes the top level properties optional, for example, and this will not be optional. If we use partial, the resulting type will look like this. It will have blah 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 blah. It should have preference which is an object, but what is inside is it's up to you if you want it to be present or not. The theme and notification properties are still required, assuming preferences is provided. Okay, the theme and notification properties are still required, assuming preferences provided. Yeah, but like saying like preferences should be there as an object. It could be an empty object or an object with just one, or have both, right? Isn't that no, they're still required as a okay. No, what I'm saying is not right, because okay, these are like not required. It's like saying they might be there or not, but these need to be there, right? That's like how we're using this question mark. If we use partial determinant type, would look like this. Makes only the top level properties optional. Okay, this one makes some types optional. The top level properties optional. The modification will still be required, assuming is provided. But if it is not provided, okay, it's not provided. It's just not there, bro. So these ones like should be there, but ID name preferences are optional. Okay, yeah. Assignment: fix the compile some bug in the update function. You should accept a user object, but where each property is optional, so we're just gonna use the partial thingy we just learned. Yeah, we're gonna just pass this inside partial, and that's nothing to update. If nothing was provided, we'll make ID and email optional. Okay, I see. Okay, instead of okay, this would like okay, yeah, this will make like our type reusable. Like say if like some object might need this, but might not have both. Instead of just making this type which might be used by some function which needs everything, we can just use the partial, which will make those things optional where we're using it. So not to create the entire type with the optional properties. Like it will be like this, but then if a function is saying they might be there or might not be there, then that function will just use partial, and then the others that actually requires that type will just use the type as is, and everything will be required. Okay, I see. Required utility type. The required utility type does the opposite. Okay, that partial like makes everything optional. The higher level things optional. Okay, and so required, I'm guessing it makes everything required, I guess. That's the opposite of partial. It enforces all properties to be required, even though that were originally optional. Okay, even if, okay, this is very, very interesting. Even those types that were originally optional, now they are required. Everything, like they didn't say anything about lower level or anything. Everything is required. It's a practical example of using required. If we have this type, and like this is very, very interesting, because like if a function is expecting an object of this structure but expects everything, you want everything to be required, but you have this, you would have just gone out of your way and created another type with similar things. No, like this required like handles that. All properties are now required. Okay, my required blog post to required blog post. Okay, my required blog is equivalent to, yeah, now this will be equivalent to this. Okay, like even required works only on top level properties, because this is nested here. This won't be checked. So if there was a required inside, like nested in an object, or okay, it stays like that. Okay, as before, required tuple is not recursive. It only affects the top level properties. Yes. Assignment: our user emails and phone numbers are usually optional but become required when it's time to make a purchase. Okay, got an info, add to billing info. They are optional but become required when it's time to make a purchase. Complete the billing info function. Use required to enforce the content info properties required. Return the string billing info, replacing with their respective fields. Okay, so we just pass this using the angle bracket syntax into required, like this. Okay, this is very interesting. So it's partial, which makes everything optional. Required, which makes everything required. The top level things required, to be precise. Read only properties. we didn't skip anything, right? Okay, the required read only. Okay, let's say okay, read only utility type. The read only utility create a new type. Well, all of the top level properties are read only, preventing them from being reassigned after initialization. Okay, this is interesting. So it will make this and this and this read only. This is this inside the nested inside this property, which is an object, so they won't be checked. So this will be read only. So okay, type read only, so it will be equivalent. It is the same as this read only, read only. Okay, assignment. Let's make sure that the API. So we use the same syntax, just read only, and then they're using capital from partial. Then required here to read only, they're using capital. Okay, let's make sure that the API config imported by our server can be modified. Complete the import config function. It should return the given config object with all properties marked as read only. Let's complete the import config function to return the given config okay, so we just return this object inside required. Okay, yeah, that's that. Read only utility type partial. Record the utility type, man. This partial, this required, and read only. They are useful for changing the kinds of properties in a type, but there are also utility type that change the shape of the type. The record utility type creates a type with a set of properties k properties k of type t. Wait. This is just saying this is like an object of string number pairs, right? That's like how I used to understand them. And let's just say partial, required, and read only are useful for changing the kinds of properties in a type, but they are also utility type that change. They are also utility types that change the shape of a type. The record utility type creates a type with a set of property k, yes, of type t. Yes. Okay, property k of type string. Okay, property k of is a string of type number. Yes. And then we can add any string property key. If we do this, we'll get an error. Type string is not assignable to number. This string is not assignable to number. Okay, I've seen this. Like I once asked GPT about this when I was looking at some code. Okay, you might be wondering, wait, there's another way to define key value pair in TypeScript. Well, yeah, I know we're up to 5 different ways at this point. However, one of the more practical use cases of record is to ensure that all specified keys in a union are present in an object. Okay, so player role, tank, Euler dips. Using a union literal types as keys. This is just saying, okay, this is it. Like this, we're talking now. This is TypeScript type system going. Okay, let's so record is just saying role capacity is just an object. Okay, it's just like it's just an object. It's a type of player, key, and number value. So the property name should be coming from player role. So if it's not, you get a type error. TypeScript error if any role is missing. Okay, so they are all required. That's interesting. Property Euler is missing in the type. Okay, we can add additional keys in the union. Okay, yeah. Okay, property support does not exist. Okay, yeah, this is interesting. It's fantastic for exhaustive lookup tables and configuration objects. Okay, so you have your status codes, then you have your status message of that, and then you just create this as that. Okay, function gets status message. It's taking this type. No, it's taking a status code and returns a string, and then it just checks the status message using that code that it will receive. Okay, TypeScript is good for error, for catching errors early. I see why it's good. Run the code assist and notice the compiler error, fix the bug, and get status function. Okay, so what are we doing here? What's this? Okay, we're missing something. Okay, we're missing responding. Okay, waiting message, and then responding message. So we just create that. We just write responding colon and then put responding message. Like, yo, they're doing too much. Why did they do it like this? Just put the strings there. Okay. Pick utility type. Okay, I've never seen this in my life. A record, I know about record. Okay, they pick utility type creates a new type by selecting a subset of properties from an existing type. For example, if you have this interface, ID name, this reviews. Okay, type product summary, pick product, and then okay. Create a new type by selecting a subset of properties from an existing type. So okay, ID, P1, name, price. Okay, I mean, this sounds useless, yo. I don't know if it's just me. Okay, it's just saying like it creates a new type by selecting the subset of properties. Okay, subset. So it selects like a subset, and it's like those will be like an improp, a proper subset, a proper subset. Yeah, and then you do it like this. So it should be coming from products. These are like the property keys that are coming from products, and you're saying you're creating a type with like you're creating a type, and then you list like, okay, like I see why you could have, like, if like they are existing in product and you're trying to create another type with things that already exist here, instead of just going on and creating another interface and calling it product summary with name, with ID, name, price, you just do pick, and then because they already, those names, those property keys already exist here, you just pick that subset. I mean, this, and like this way, if there's anything you need later, you can extend by just coming here and extending. Okay, I'm not complaining. Content valid product, product summary of type product summary, which is just an array of objects of type product summary. Okay, product summary is here, and then ID, name, price, and then TSC error, object literal may only specify non-properties, and description does not exist in type pro. Yeah, if you add an additional, you get an error. Pick is very useful for creating quick types for functions that don't need anything from an additional type. Yeah, that's what I was taking. Like, if like instead of just creating another type, if you have like an existing type and you just need some in that existing type, you can just take it because it's like a proper subset of that thing that's already there. I fixed the bug in user without ID type so that it has 3 properties it needs. So like it needs name, email, and age. Okay, you just put them here separated by comma thing, no, separated by you see, like, why you need to go back to the syntax. You think you get it, okay, you understand it, but the syntax is not there in your head. I was thinking they're separated by comma and then they're separated by these lines. Yeah, see, now this is why like I like to program as I'm learning, because like you're really like nailing the syntax in your head. Omit, there are so many utility types that are built in TypeScript. Okay, the omit utility type is the opposite of pick. So instead of picking a subset, what does it do? It creates a new type by excluding the set of properties from an existing type. I find this one to be very useful when removing sensitive or unnecessary properties from a type. For example, maybe you need to remove a password field from a user object before responding to an API request. Okay, so instead of picking a subset, omit, I'm just guessing, I haven't read the bottom code. Instead of picking a subset, it takes everything and removes some, which you will list here, which once you want to remove using the same syntax. Create a safe user representation without sensitive data. So if you have this interface, so it will be that bada bing bada boom. This will be this type but without password hash and updated at. So it will be the same type without this and this. It will still have created at though. So get profile self type. It's returning something of public user, which is here. Oh, why am I seeing updated at? We need to remove there. Let's see. Okay, so we're creating a type database user. Okay, there it is. This is the type we created inside that function. Convert public user. Okay, it's returning of type public user. Okay, yeah. So we have this of type database user. So convert to public user, explicit conversion for clarity. So you would public user. Okay, public user of type that, and then you just remove those. If you like try to put password hash because it was removed here, you get an error if you're using this type, because it is not a non-property of type public. It's not a non-property in public user. Yeah, that's that. And then you would return public user after removing this, and I mean it will have, yeah, it has 6 initially. We removed 2, so it will be 4. Yeah, we return public user, it would work. So why did we, okay, like we're getting this from the database user here. So if, okay, we have, okay, yeah. Okay, so like except they said you use this for filtering some things before responding to an NPR to remove sensitive data, or maybe we want to send somewhere, like if like getting something like this from the database and you don't want to pass I'm falling in love with programming. Oh no, like I just want to program right now. I don't know what's going on. I just want to see this. I just want to write something like this and just see it happening with my own 2 eyes. Okay, so like if you're returning something like this from the database, and you can just send the passwords and stuff to maybe a user front end and whatever, so you would filter things out using the omit. Okay, the omit utility type that is built inside TypeScript. Okay, fix the bug in user without ID type by omitting the ID. So it is returning a user without ID. Here you would use omit, and then I use that syntax. It's a colon, it's a comma, and then use the syntax to omit the ID. We have name, age, and email. Yeah, and then we're responding with some type of user ID. So like here we just destructure the thing into an object and return that thing inside an object. Yeah, because this is of type user. Yes, this is of type user. So yeah, we'll just destructure name, email, and age from the user. This is like a nice way of filtering, instead of just recreating another thing like this and then doing like this. You just use this destructuring thing syntax and then return this as that. Maybe I should just write it so quick, because I haven't written code and I feel like we're going to the last thing and we haven't written a program. Like I can't just read and not write a program even though it's like very, very easy. Hey, didn't you copy? So real quick, yeah, you would just use the omit and then do this. And then what are we omitting? We're omitting the ID, and then your program would work. Right. Very, very interesting, very, very useful. I am going to be reviewing them again tomorrow, because like I'm probably gonna forget after doing maths. Nope. This will be the end of today's video. I'm not touching generics. I am not touching generics. Okay, let me just take a quick look. Okay, it's not even too much. Okay, this generics. But I've done them in C++. They're called I forgot something. I've read about them in C++ because we do C++ at school, so like obviously I've read them. Okay, that's generics. Is that it will be done tomorrow. Okay, Saturday tomorrow we'll have time for this. Okay, so we have finished some utility types that are built in TypeScripts that are very, very useful. First, I was saying pick. Like it's not very useful, but now like I see, okay, I am going to be using them. Like I just want to see these things in use, guys. I just want to problem. Can't wait to write those little projects that I'm gonna do in TypeScript after, like, actually it's after tomorrow, so I'm just gonna start. Okay, next week actually we're going to be writing projects in this channel in TypeScript using the type system, avoiding using GPT. So that will be today the end of today's video. I hope you enjoy the video, and I will see you on the next one.